SwayamPrabha. Digital India. Educated India.
So let's move to lecture 6, which is we are going to talk about selection of materials. Till now what we have understood is we have understood about matrix, fiber, forms of fiber, then we went into little bit of calculations in a tensile load, in a transverse load along the longitudinal direction, along the transverse direction, what happens to the load which it takes, and what is the critical volume fraction we need for making a composite, and what is the minimum we need. So there is a small difference. We did calculations and last class we saw, and we also introduced two things. One is called as weight fraction and volume fraction. Volume fraction is used for theoretical work and weight fraction is always used for manufacturing. And then what is their relationship? How do we derive from weight fraction, volume fraction, and volume fraction to weight fraction? So then we saw different types of testing of materials. That means to say a composite is fabricated. What are the different kinds of testing we do so that we can try to choose the best out of it. Now understanding the testing, let's move to the next stage, which is called a selection of materials. Selection of materials is a very important topic because here we are trying to cover what is the influence of each mechanical property with respect to performance and with respect to cost. So we will in this lecture we are trying to have content as material selection. What is the need and reasons? Next, what are all the material properties, the material selection process, and the material selection methods what we follow here. So material selection is very important. So here what we do is we try to take the behavior and the performance of the product both, depending upon the type of material which is used for making a part. For example, a chair can be made out of steel, a chair can be made out of wood, a chair can be made out of polymer material. So what does a customer want? A customer, as far as a customer is concerned, he is more comfortable. He looks for a comfort to sit in a chair. Second thing, after the event is over, the supplier or even a customer would like to have a stacking sequence such that he can store after the event is over in a very short place. So these are the two requirements. Generally we have a customer. For doing this, you can choose wood as a starting material, steel as a starting material, and plastic as a starting material. Polymer does not corrode in due course of time. So polymer has a longevity in work. The wood based and the steel based, they always have a environmental influence on the product, and over a period of time they both get deteriorated very fast. So both the steel chair as well as the wood chair can be folded. You can think of a folding process and then stacking it together. But the only thing is, when you work with steel or when you work with wood, the number of parts which are involved for assembling and making a chair is very high. So the assembly process is very high. The maintenance cost is also very high. Now, keeping all these ideas, we are supposed to choose a particular material. When we choose a particular material, keeping all these things as prerequisite, then what we do is we choose a material, then corresponding to that material we choose a process. In fact, there is one more important aspect in all this choice making is the cost. What is the cost I give for that product? So keeping all these things, cost, mechanical properties and other endurance properties into consideration, we have to choose a material so that we make the customer happy. So here the behavior and the performance. Performance is how good the product performs or how happy is the customer. So performance of a product depends on the type of material used in the product. There are more than 50,000 materials available for design and manufacturing of a product today. The spectrum is very large. Gone those days, you have only 3 parts, 4 parts or 4 different materials. We choose that and start making it. People thought this part, which is a structural component, this has to be made out of steel, is now replaced by polymer matrix composite. The weight has gone down, the performance has enhanced. And as far as polymer, we have already known that depending upon your requirements, you keep adding ingredients to meet out your properties. So there are more than 50,000 materials available for design and manufacturing of a product. Every material cannot be a right choice for a given application. Therefore, a suitable selection has to be done, or an optimum selection has to be done for choosing a material. Depending on the selection of a material, the product exhibits changes in design, processing, cost, quality and performance. Interestingly, the shape of the product can be changed to meet out the requirements. For example, if you think of having a square shaft, it can be made circular, keeping manufacturing as a important giving more weightages to the process. We can always make it cylindrical. Earlier, square sections or rectangle sections, box sections were thought to be very difficult in manufacturing. Today, there are a lot of new process, and process ease has happened. So we can design any component and we can manufacture the same. So what is the need and reason? So the need for material selection: without a proper knowledge of material selection, opportunities offered by advanced material systems can cause decreased competitiveness and can lead to loss of material. So if you make a wrong choice of material, for example, sensors were initially thought of to be made by glass, then they moved to silicon, and today they are made out of polymer. Polymer is lightweight, roll-to-roll manufacturing can be done very easily. So if you don't have the proper awareness, knowledge about the material selection, then you will not be able to push your product, or your product will not be much successful in the market. With the increasing of customer demand, so today customer is becoming more and more demanding. So what he wants is, he wants a very lightweight part which can do multiple operations or processes, and which is having very low maintenance with low costing. So you see, all these demands which customer puts in front of manufacturing is all contradicting to each other. But still he says, I will give you this much price. So that means to say, he wanted to buy the product in a very, very economical manner. So the customer demands for high performance and quality and competitiveness among company has increased. So a proper choice of materials is very, very important. And today the government norms have also become very stringent. They are now talking about a green earth. So wherein which the material which is being chosen for making a product, what the government norms are pushing very hard is, it should have minimum carbon footprint, it should be biodegradable, or it should be recyclable. So these things put a huge demand on the designer to make a proper choice, or to make a selection, material selection proper to achieve the product. So the other 2 points which are very important is to redesign an existing product. So whenever a product is made, if the product is made out of a material which is the ultimate, which cannot be recycled, which cannot be reworked, then there is a huge problem in those materials. So today what is happening, the designer is told that please give a small window such that we can try to redesign or redefine the product such that it can meet customers, or it can be made to meet to a set of customers. So to redesign an existing product for better performance, lower costs, increased reliability and decreased weight, etc. are some of the reasons which push for material selection. So to select a material for a new product, we always have to do material selection. Let's take an example. A part can be made by injection molding, should be made, okay, so let's take a simple example of a wheel rim which is used. So earlier days, these wheel rims were made by casting. The same wheel rims today are being made by pressure die casting. And these wheels today, they are being added more reinforcement using carbon fibers and other things, and they are thinking of making these wheels by injection molding process. So basically it was initially cast iron. From there they went into aluminum, lightweight, high strength, and mass production was, batch production was done, and from there they are now trying to move to injection molding process, keeping polymer there, reinforcing with carbon fiber, making it light and making it high performance, such that they can be doing a better performance to the customers. So for example, if you have a wheel rim to be made, this can be made out of the three choices. One is casting process, it can be made by die casting process, or it can be made, today they are looking at injection molding process. So injection molding process, polymer is used, and the carbon fibers, I said the carbon fibers can exist in several forms. So they try to make a three-dimensional reinforcement and inject polymer into it, and wherein which they are also thinking of placing a location for inserts. So this is what it is. So when casting process was thought of, there was lot of machining operation which was included. We were not able to make near net shape process, near net shaping, which is the big advantage of polymer matrix composite. So this was not being achieved by sand casting process. When it came to die casting, yes, we were able to make, and when it goes to injection molding, we go very close to the final product itself. So for doing this, you should have a proper knowledge about the material selection for the product. So this is just a recap. You can see that we saw about thermoset, thermoplastic composite. Thermoplastic, the major thing is recyclable, recycle. But here it is non-recycle. The fiber volume fraction, it can go from medium to high, it can go from low to medium. Why? Because when you keep a preform and the matrix, if it is in a liquid state, so it can easily flow and try to take a shape. But whereas in thermoplastic, you always apply a pressure wherein which you keep a preform of reinforcement, and you apply pressure and then push it inside. So you can't go more than medium. So here you can go to as high as 80 to 90%. So here the fiber length can be continuous, it can be discontinuous. Predominantly here it is discontinuous. Today it is getting moved to continuous. The mold time in thermoset is somewhere close to 4 hours. But here you see it is less than 5 minutes. So if you are looking for mass production, then thermoplastic composites are very good. So the pressures which are involved is 1 to 7 bar. We will see where is this pressure used in thermoset when we talk about manufacturing of composites. Here the pressures are very high. So when the pressure is very high, what happens? It is a viscous fluid flowing, and then you have a preform already laid there. When you inject it at a higher pressure, since it's a viscous fluid, the preform can move. So it is very difficult for you to hold the preform and then inject it. If at all you put a spacer, that spacer becomes an integral part of the composite, spacer or a holding device. Material cost is low to high, it is low to medium. Safety handling is good, it is excellent, because predominantly thermoplastic polymers are solid, they are available in pellet form, they are also liquid form. The solvent resistance is very high, the solvent resistance is low, because the material can be etched if you use for acid applications. But whereas if you choose a proper thermoset, it is very high. Heat resistance, it's almost the same because it's a polymer material. The storage life is very good, and it is indefinitely. So that means to say it can be there for any time. So this is a recap which we already saw. So these are some of the properties you should know before making a choice for making or fabricating a composite. So the material and selection process can be now divided into 4 things. One is understanding and determining their requirements. See, that is the biggest problem. As a manufacturing engineer, we many a times don't understand the customer's choice or the customer's requirements. So that is what in a design process they say, please do an empathy study. So empathy study means you become a customer for that product and you list down what do you expect from the product. So the material selection process first starts from what does a customer want. So understanding and requiring the requirements. Then you make a selection of a possible material. Then what you do is then you make a determination of the candidate material. Then you do a testing and evaluation before the product goes into the market. So here first you understand the customer, then you try to select all possible. So that means to say you choose only polymer is good. So now in polymer you have a 3 classification: thermoset, thermoplast, elastomer. So now you decide, no, I will use only thermoset. In thermoset you have polyester, you have epoxy, you have vinyl ester. So you have so many things available. So in this, which one do you choose? And again, after choosing it, what should be the reinforcement? So those are possible things. Then what you do, you determine the candidate material. So what you do is you cannot go by just by qualitative parameters. You have to convert the qualitative into quantitative values. When you convert into quantitative values, you have each material will have some rank or weightage or whatever it is. So we will determine that. Then what we do is we identify a candidate, then we do testing and evaluation. So the first step is in identifying a material is to define the requirements of a product. When you look at a product, generally a product does not undergo only one property, or the product never demands only one property. There are many properties. For example, let us take a chair. So in a chair, we always think that okay, there is compressive load alone, but there is compressive load. On top of it, you sit down and slide and move up and down. So when you do it, your hip goes sliding. So the bottom bench where you sit, there you have some sliding load coming up, and the place where you rest your back, there also you slide. So that is second point. The third thing is roughness. It has to be as smooth as possible. Fourth thing is when you sit on a chair, we sit as an impact load. When you sit as an impact load, the chair has to take impact load also. So the toughness should be high. Now you see, we thought initially it is compressive, but now you see a list of properties are required. Mechanical properties are required from a product. And then on top of it, the other things are the color, the texture, all these things play an important role. The first step is to identify, in identifying a material, is to determine the requirement of the product. Once that is done, then the next step becomes very easy. There may be several benefits a material can offer, but some requirements are critical to the application. So out of these so many things, whatever I said for a chair, by and large, a chair has to take a compressive load, it has to distribute the loads between the 4 legs, and it has to have impact load. So this is very important. So first what you do, you will list down all the properties what you want from a product. Then you picked up the most critical ones, and then you try to solve the most critical ones. So they are called as primary requirements, and there are something called as secondary requirements. Secondary requirements we will try to accommodate, but we will not give them more weightage. Suppose you don't do this analysis. In industrial engineering term, they do something called as ABC analysis. So if you don't do this ABC analysis, we will try to take a property which is very trivial or a secondary property and start giving more weightage for them, but ultimately the customer will not be happy. So there may be several benefits a material can offer, but only critical applications you should look and choose a material. Some of the requirements that need to be considered, I am listing down. Majority is mechanical, then it is environmental. One is strength. What are the strength? It can be tensile, it can be compressive, it can be shear, right? And it can be shear, etc. Impact resistance, as I said, it is very, very important. So then it is thermal resistance. This is what I was telling in the last class about service condition. what is the ambience it is present, in which ambience it is present, so that it is expected to perform. Then comes humidity. See, the relative humidity in certain parts of the country, you can see it varies from, the humidity varies from 10%, it goes up to 95%. So, you see so much of water in the atmosphere, so your workpiece, your product should not absorb. Then on top of it, chemical, and then electrical. So, chemical is corrosive environment, electric is sometimes we use it for insulation properties also. Then process. So, this process is directly process, production rate and cost. These three are interlinked. And we are always looking today for green process. What do you mean by green process? Two things. One is minimum energy and minimum damage to earth. So, this energy can be in terms of power, electrical power, it can be thermal power, it can be pressure, whatever it is, right. And here minimum damages after the ingredients of the process should not, you should know to disperse it in a fashion such that it does not damage Mother Earth. So, we are always looking for. So, these are some of the selection processes. So, these are some of the requirements in the selection process to decide a material. So, selection of a possible materials, as I told you, a wood example, a polymer example, a steel example for a char. So, we will keep that example and walk through this slide. Based on the requirements of application, possible materials and manufacturing process that meet minimum or maximum requirements for the application are determined. So, that means to say you have to list down all the processes and then all the properties, and then you start ticking them. So, you should have a big matrix in front of you. Then one should set the minimum or the maximum requirements that the material and the process must possess and should result in a positive yes or a no answer. So, now we are getting into the grading of it, right. The purpose of screening phase, the purpose of this phase is to obtain definite answers or to whether a particular material and a process should be considered for this application. Many a times what happens, this is the domain knowledge we have. These are the new materials which come into the market. We have a domain knowledge. We have to go here and pick that knowledge, and once you start picking this, so now what you have is your domain knowledge is increased. So, new and domain, it gets expanded. Now, this entire zone is now the amount of exposure you have, so that you choose a proper thing. Generally, the new material comes out of research / magazine / industry introduces it, right. And the domain knowledge predominantly can be handbook, which is a static one which gets revised once in 10 years or something. Okay, so you have a knowledge plus you go for handbooks, material supplier, and then try to get. So, all these things are used for choosing, for selection of a possible material for making a product. Why am I spending more time? Because many a times we understand, sitting in a room, we think that this is what is the customer's choice and we start doing it. But really, if you go down to the customer, get his details, list it down, analyze primary and secondary, then only you will be able to make a proper choice. So, determination of a candidate material. In the conceptual design phase, more than one material. So, if you see that, so after you do a customer survey, a designer tries to develop a conceptual sketch, conceptual design. So, here he puts in all the functions he gives very rough shape. He goes back to the customer and then he asks whether it is fine. Moment conceptual design is analyzed, then is cleared or it is accepted, then he goes to the engineering design. Engineering design, what he does is he tries to talk about shape, size, tolerance, etc. Okay, and then he tries to go for manufacturing. Okay. So, this is how it is. So, here the conceptual design phase, more than one material system and the manufacturing methods are selected to provide a wide choice of creativity and innovative design. Suppose at the conceptual stage itself you freeze only one particular product, everything you freeze, then what happens is you will not be able to go back to the customer and say, here are multiple choices, you can choose whatever you want, because the customer will always prefer to have a choice. The customer today is more intelligent and he never takes it by force. He never picks a product by force. He would always like to have his choice because he pays the money for it. So, the cost, weight, performance characteristics of each of the design is done. So, when I say cost, so I try to integrate all the mechanical properties, somehow I try to link it to cost. And weight, because no customer wants to carry a very heavy, for let it be a very economical, but if the product is very heavy, nobody would like to have. So, cost, weight and performance. Performance means in terms of reliability, very low maintenance. For example, a software, you can do multiple tasks, very low maintenance. So, that is the performance. You buy a mobile phone, you have several apps loaded on a mobile phone, an operating system, several apps. So, that is performance. Right. So, performance this thing. So, for each of these design concept, then what he does is then he tries to take about the stress. This is where an engineer comes. Stress and other analysis must be performed to evaluate the design. So, here I said in the next process, that is engineering design has to be done. So, he does it. So, when I talk about stress, it can be using first principles or it can be using finite element analysis or using some simulation. You try to make and show in a virtual pattern and understand whether everything is fine. So, software and other tools can be used to reduce the cost and the time of the product development phase. So, what happens, there is a terminology called as product life cycle. So, a product life cycle, nowadays what is happening is the product life cycle for a component is reduced from 18 months. Earlier it used to be years, then it has come to months, now it has come down to weeks. Okay. So, every new week a customer expects a new product from a particular company or a more. He just tweaks the existing one and gives a better performing component. So, the product life cycle time, this is what we are trying to talk about, product life development phase. Product life cycle time goes down. Make and break approach must be avoided. That means to say, rather than doing all this involving understanding the science what is going behind, we just make individual components and then we do the testing for it and then we say, okay, this is good and this is bad. The only thing is it takes time, it takes cost, but this is the best method. Time is more and cost is high. Right. And here if you want to do some small optimization between parameters, then it is very difficult to do in this make and break approach. So, here in the earlier one you have understood the science, you have done the simulation, you have enough of understanding of the material for its performance. A good understanding of the product requirement will greatly help in making a right material and a processing choice. This is very, very important. So, only after making a right material choice and a proper processing choice, we will be able to deliver the product in a cost effective way. Then testing and evaluation, there are several ways of testing. One is you test the prototype, then you test the final product, then you do endurance testing, right. These are some of the ones which you endurance testing. So, these are some of the things which generally we do before a product is released into the market. The prototype made prototype parts are made and they are tested to validate the design, show it to the customers and do some scale down testing of the product and see their performance. Depending upon the seriousness of the application, the number of parts to be tested are decided. For example, if it is a biological part, for example, where in biology these composites are used. For example, now the differently abled people, there are a lot of aids which are getting developed so that to make their life more comfortable. So the crutches, the wheelchair, so all these things are nowadays developed in composite so that it is light in weight. So here what they do is they try to do field testing, and these testings are very critical. So it has to undergo an ethics committee test, it has to be tested for a longer period of time, and then they have been brought to the application. Whereas engineering application, suppose you do, there the testing is not considered to be as severe as the biological testing. So here depending upon the criticality of the part, the number of samples to be tested is also decided. So for aerospace and automobile parts generally requires more test. Generally in aerospace we require very, very stringent testing. Of course, yes, in automobile also, but not as stringent as aerospace. Generally requires more test to ensure that the functional parts safely and reliably under various service condition work. So here under service conditions are, so for aerospace it is minus 50 degrees C to minus 50 degrees C it has to work. Whereas when you talk about automobile, it generally works between, you can take it from 0, very rarely it works on minus, to up to 50 degrees C. Maybe this 50 can go up to 50 degrees CS, because that is the atmospheric temperature we have, and maybe sometimes it can be tested for even minus 10 degrees Celsius, whether the engine components work, the spark plug cranks, all these things can be done. So these are the service conditions, and it can be altitude also. The large property database is created to understand the behavior of the part under various service conditions. So today what is happening, we have handbooks wherein which the service conditions are also reported. What happens to the performance at room temperature? We recently worked on a project wherein which we were trying to make caskets. So caskets for two mating surfaces, and we made perfect casting at room temperature. But we did not realize when it gets for a vacuum testing, these caskets fail miserably. So room temperature perfectly it worked. When it went for vacuum, that is a service condition. So when it went for vacuum, all these caskets failed. So service condition is very important, and today you get handbooks which talks about that. So again, when you talk about corrosive environments, so corrosive environments like along the beach you are trying to construct, or along the beach you are trying to keep a boat. So what is the corrosive behavior, its impact on temperature? So now today these handbooks are coming up, and there are also research publications coming up, and then we do it. The next important thing is the evaluation has to be done both in static and dynamic cases. Static cases, okay, we do a tensile test only for one component, but what happens is, as and when the component is dynamically loaded and unloaded, what is the response deterioration of this product or this property? This is very important. Today we have started looking into dynamic testing also. That means to say we apply a cycle, a fatigue cycle or some cycle, compressive cycle, tensile cycle, compressive tensile loads, compressive loads, tensile loads, compressive tensile loads, so that we get the output. So that static and dynamic tests are conducted, and then we try to take the conditions out. So then the adhesion, which I have already told, and the effect of thermal cycle is also talked about, because this stone impingement is nothing but erosion study. For example, we think of a turbine blade which is used in aeroplane application. A small droplet tries to hit at the surface of the turbine blade. The velocity with which the plane goes, it's around about 3000 or maybe 300, 400 kilometers per hour. That's the speed it goes. So at that speed, even a small water droplet becomes a stone impact. So we are also trying to look at those things and understand what is the process. Generally speaking, polymer damage resistance is very poor. So this is one area people are trying to add ingredients and make sure that it withstands for damage resistance. For example, a bird hit or a spanner drop on a wings of a plane. If in polymer, the crack initiation takes lot of time. Moment a crack initiates, then the growth of the crack is very, very fast.